there, and welcome back to another video. Now, in this one, we're going to take a look at how to solve a pair of linear simultaneous equations using matrices. So we're going to make use of some linear algebra here. Now, hopefully you've seen or you've been introduced to matrices before. And one of the very first things you might learn is that for a 2 by 2 matrix, let's say A, so I've written down A here, and it's just ordinary, it's A, B, C, D. And it has a non-zero determinant, so det A is non-zero, then we can find the inverse. Now, just before we get started, if you haven't done so already, please do consider hitting that subscribe button. It really does help me out and it helps my videos reach more people. Of course, if you enjoy the video, leave a like and a comment down below of something you'd like to see. So, we've all seen in GCSE maths or possibly some other qualification how to solve these basic simultaneous equations. So something like this here. 2x plus y equals 5 and x minus y equals 4. We've seen the method how to do it. You might add or subtract some combination of the equations in order to eliminate a variable, or we may substitute. But let's have a look at this. We can now use our knowledge of matrices to help with this. So we have 2x plus y equals 5 and x minus y equals 4. So we're going to create a matrix A, and we're going to say this is equal to the coefficients of x and y. So the first row is going to be 2 and 1, and the second row is going to be 1 and minus 1. So that's the coefficients of these two and these two. And we're going to also have a matrix B, and this is equal to 5 and 4. Okay, so let's add them in. So this is just an ordinary column matrix or vector. So now, essentially what we have now then is an equation AX equals B, and this is where X equals xy. Because if we now look at our matrices, we have 2, 1, 1, minus 1 times by xy equals our B, 5, 4. And if we multiply out these two matrices, we will indeed get what we were expecting. So you get 2 times x plus 1 times y, and the first one, and 1 times x minus 1 times y. Okay, now what can we do? Well, because our A has a non-zero determinant, let's check. So determinant of A, well, that's going to be 2 times minus 1 minus 1 times 1, which equals, so minus 2 minus 1, which is minus 3. And the important thing here is that it's non-zero. So, as det A is non-zero, A inverse exists, and we can find it. So A inverse equals, so it's 1 over det A, which is 1 over minus 3. And then if you remember from up top, it's D minus B minus CA. So let's have a look. Well, D is minus 1. Minus B is going to be minus 1. Minus C is also going to be minus 1. And A is going to be 2. Okay? So you remember we have our equation AX equals B, but now we can multiply by A inverse. So this gives us that x, our vector we're after, so x and y, equals A inverse times B. So let's do that. A inverse was our minus a third, minus 1, minus 1, minus 1, and 2. And B was our column vector of the answers. So that was 5, 4. Okay, so let's calculate this. It's going to be minus a third, minus 1 times 5 plus minus 1 times 4 is minus 9. So that's multiplying these with these. And then for the bottom bit, we multiply these with these. So we're going to get minus 1 times 5 is minus 5 plus 2 times 4 is going to be minus 5 plus 8, which is 3. And simplifying this, we get minus a third of minus 9 is just 3 and minus 1. So in other words, x equals 3, y equals minus 1. And that is our solutions. Now, obviously, for simultaneous equations such as this, it may be sometimes easier to just solve it the way we know how. So the way we'd usually do it is we'd spot that we've got a plus here and a minus here, and the numbers in front of the y are the same, so we can just add them in order to get 3x equals 9, and so x equals 3, and then because x equals 3, we just substitute that back in here, and that tells us that y equals minus 1. But I really like this method of using matrices. Really hope you enjoyed. Do leave a like, comment, and subscribe. See you next time, guys.